Hey guys, welcome back to General Chemistry Chapter 1. Today we're going to talk about density. One of the main reasons that your General Chemistry courses put density here is because it gives us an opportunity to practice significant figures, so reading instruments, and then mathing with those significant figures. So we get to do multiplication, division, and addition, subtraction. So density, of course, is a skill that we want to teach general chemistry students, but it's put here because we get to practice all kinds of things. So first, let's talk about what density is. Density is defined as the ratio of an object's mass to its volume. So that's the word definition. Here you'll see kind of the mathematical definition, what that looks like in a formula. So density equals mass divided by volume. Units for density typically are grams per milliliter, mass in grams, volume in milliliters. Oftentimes you'll find other units for volume like centimeters cubed or cc's for those of you that have a medical background. All of those are the same thing. A milliliter, centimeters cubed, or cc, cubic centimeters, are all the same thing. Density is an intensive property of a particular substance. So this means it's independent of the amount. So for example, the density for lead is 11.3. No matter if I have a teeny tiny little nugget of lead or I have a huge block of lead, if I were to determine the density for each of those, it would still come out to 11.3 grams. So intensive properties can be used to identify substances that maybe we don't know. And that's exactly how we'll use density in general chemistry. Intensive, the opposite of that would be an extensive property. So an extensive property depends on the amount of a substance you have. So for example, mass, if I have a teeny tiny little hunk of lead, it's going to have a small mass. If I have a huge block of lead, it's going to have a huge mass. So mass would be an extensive property. It depends on how much I have. Volume is also an extensive property. All right, so let's look at a really simple example of density and work it out. So what is the density of a sample of liquid that has a volume of 22.5 milliliters and a mass of 27.2? Well, we're going to use our formula here for density. Density equals mass divided by volume. So to determine the, go back. So to determine the density, we're going to put the mass on the top. So the mass is that 27.2 grams. And we're going to put the volume on the bottom. So the volume is that 22.5 milliliters. Okay. So at this point, we are going to plug that into our calculator, chug our way through the problem. But don't forget, folks, we have talked about significant figures. So when I get this calculation out, then I'm going to determine the correct number of sig figs. So first, we're going to take 27.2 divided by 22.5. And my not so smart calculator spits out a number that looks like this. Density equals 1.20888888. Okay. Thinking about significant figures. So first, what order of operation are we doing? We're doing multiplication division. What is the rules for multiplication division? The weakest link. So my top number has 3 significant digits. My bottom number also has 3 significant digits. So when I report my number, I am limited to 3 significant digits. Okay. So to correctly report this value, I would report density as 1.21. The units here are exactly what you see. So we just simply rewrite grams on top, milliliters on the bottom, and often we refer to that as grams per per milliliter. So that would be the correct answer. That would be all the points. 3 significant figures. Units would be grams per milliliter. So this is a pretty easy, straightforward problem. Things aren't always that easy. What if we have like an irregularly shaped object? What if I have a piece of metal and I've got little pellets of metal and I want to know what is the density? Well, there's going to be a couple extra steps. And this is what you would perform in a general chemistry laboratory. So let's say I want to know what the density is of this unknown piece of metal, this cylinder of metal here. Well, if I want to know density, remember the formula is density equals mass over volume. I'm going to have to determine the mass, and I'm going to have to determine the volume. Well, mass is pretty easy, right? I just walk over to the scale in my general chemistry lab, and I plop the piece of metal on the scale. So here we see that this metal object weighs 68.60 grams. I would write all 4 of those numbers down. Determining the volume of this object isn't as easy. It isn't as straightforward. So with this irregularly shaped object, I maybe can't measure it with a ruler or some other measuring device. So the way that we're going to do this is called volume displacement. So we're going to look at how much water this particular object displaces, and that's going to tell us the volume. Okay. So we would start with some water in a graduated cylinder. It really doesn't matter how much you start with. What matters is you correctly write down how much it is that you start with. So I'm going to put water in this graduated cylinder, and I measure it, and it reads 35.5 milliliters. Then I'm ever so gently going to put my metal object into the graduated cylinder, and that's what we did here. The volume, of course, is going to increase. That volume is going to go up. So now the final volume, or the volume at the end, is 45.0 milliliters. So to determine the volume of this particular piece of metal, we're going to take the change in volume. So this triangle is known as a delta. It denotes change. So the change in volume is always going to be the volume at some final time minus the volume at some initial time. So final minus initial. Okay. So my final volume is going to be the volume after I put the piece of metal in. So I'm going to write that as 45.0 milliliters. And then I'm going to subtract that from the initial volume. So what was the volume before I put the metal in? And that was 35.5 milliliters. I stacked my numbers one on top of the other because I'm going to consider significant figures. So that was the reason I wrote it the way I did. So considering significant figures, this first number has 1 decimal place. The second number has 1 decimal place. So my answer is going to have 1 decimal place. Okay. All right. So now I'm ready to plug this into my calculator. So I take 45.0 minus 35.5. And my calculator spits out 9.5. Okay. So again, I keep everything to the left. I would throw away anything on the right if there was anything. So the answer that I report for the volume is 9.5 milliliters, keeping those 2 sig figs. Okay. All right. So I have the volume, 9.5 milliliters. I have the mass, remember I read that right off the scale, as 68.80 grams. So now I'm going to plug this into my equation and determine the density. So density equals 68.80, hey dyslexia, 68.80 grams divided by 9.5 milliliters. Plug this into my calculator and it spits out 68.80 divided by 9.5, 7.24210, so on and so forth. That is not the density that I'm going to report. I have to consider significant figures. So looking at my equation, I see the top number has 4 significant figures. I see the bottom number has 2. So when I report my value, I can only report 2 significant figures. So to get all the points, I would report that density equals 7.2. And then remember the units are just grams per milliliter. Okay. So that's how we calculate density of an irregularly shaped object. I hope you guys found this example helpful.